Hello. All right, guys, let's settle down real quick here. We're starting the 11:30 session, and we have 3 excellent talks. Would encourage you guys to turn off your Wi-Fi and start paying attention for a change. So first up, we have Phillipa Gill from University of Toronto, also accepted a faculty position at Stony Brook, so that's her new affiliation. Would like to welcome Phillipa to NANOG. It's her first time.
Thanks for the introduction. Yes, so my Wi-Fi is off. I hope yours is off too. Today what I'm going to be talking about is results of a preliminary survey we did of network operators to try to get a better feel of what sorts of routing policies are being used in practice. And really the goal of this talk isn't just to present results of a survey, but rather to get feedback and input from you guys and try to get a better idea of how you guys are routing traffic between your networks. So here I'm really interested in interdomain routing policies. You might be wondering why academic researchers are so interested in your routing policies. Part of the reason for this is that we spend a lot of time studying the internet. For example, we might look at existing protocols like IPv6 and try to reason about why deployment is so challenging. For example, we might look at how the performance of IPv4 to IPv6 conversion plays a role, or how the connectivity of ASs on the IPv6 internet plays a role in networks' incentives to deploy. We also look at existing protocols like BGP-SEC and try to understand how effective they'll be. So what attacks will still be possible, and what sorts of impact will they have if something like BGP-SEC is deployed in the future. Researchers also sometimes take a longer-term view, and we propose completely new interdomain routing protocols sometimes. For example, a version of BGP that depends only on the next hop AS. In this case, it's really important that we can understand today's internet so we know how these protocols will behave if they were in fact going to be deployed. In the past couple of years, there's also been a lot of interest in terms of the internet and its relationship to policy. For example, in January 2011, we saw Egypt use BGP to cut off their internet access. So we really need to understand the internet and how it plays a role in some of these government censorship and policy incidents. So why is answering these questions so challenging? Part of the reason for this is that we can't always run experiments on the internet itself. For example, if we want to study prefix hijacks, we can't go out and hijack someone's IP prefixes and see what happens just for the sake of our research project. Also, if we have a protocol that isn't fully tested, we can't go out and ask a network to deploy it and kind of just hope it works in practice on the internet. And this challenge of getting networks to deploy protocols is really a bottleneck here. Even if we have something that is fully tested and fully mature, if we had to wait for multiple networks to deploy it before we could evaluate it, we would never get any work done. Because of this, what researchers spend a lot of time doing is simulating the behavior of entities on the internet. We do this using a combination of empirical data from things like BGP monitors, as well as models of how entities are going to behave. An example of this is the AS topology, where researchers use a combination of data from BGP monitors as well as a model of the business relationships networks are using when they connect in order to derive an AS graph. Once the researchers have an AS graph, they want to understand how traffic is going to flow on this graph. And this is done with a combination of routing policy models, so modeling how networks are going to choose paths and how they're going to announce these paths to their neighbors, and also a model of traffic matrices, so how much traffic is each network sending to every other network on the internet. And it's really the second point that I'm going to be focusing on today. How do we model these routing decisions that networks are making? So the standard model of internet routing that a lot of researchers use today was developed 12 years ago by Gao and Rexford, and it was based on the practices of a large ISP at the time that they did their study. The goal of this model is to provide a simple way for researchers to simulate the decisions ASs are going to make. And I want to emphasize here that the goal isn't to capture the behavior of each of the 40,000 ASs on the internet, but rather to get a general sense of what most of the networks out there are doing so that we can run simulations. And part of my goal here today is to try to understand if this model is actually capturing what most of the networks are doing, or if you guys are seeing a lot of exceptions to this model in your network, and if these exceptions are something we should maybe be building into a new model of routing policies. The routing policy model gives us two basic components. The first is this path selection algorithm, and this basically dictates how ISPs are going to be choosing their paths on the internet. The first step of the path selection algorithm approximates local pref based on a model of business relationships. For example, on the slide here we have an ISP, and he's got a customer who's going to pay him for transit. He has a peer that he engages in settlement-free peering with. So when I say peer, I'm not talking about just any BGP peer, I'm only talking about settlement-free peers. And he also has a provider that he's going to pay for transit. And if you look carefully at this diagram, you'll see that money is basically following the arrows. What the routing policy model says is that the ISP is going to choose to route through his customer before he routes through a peer, before he routes through a provider. So he's going to want to send traffic on the link that's going to generate revenue for him. If the ISP has multiple paths with an equal local pref value, it then goes down to preferring the shortest path. And if there's still multiple equally good paths, it then goes down to an arbitrary tiebreak. So one thing this model is not capturing is things like intra-domain routing or MEDS on the route selection process. So the second part of the routing policy model is this notion of export policy. And the export policy basically says the ISP has chosen a path. Who is the ISP going to tell about this path? And it has two components. So if the ISP learns a path from a customer that's going to pay him, he's going to tell all of his neighbors about this path because the customer is paying him to do so. However, if he learns a path from a non-customer, so a peer or a provider, he's only going to send this path on to customers who are going to pay him. And the basic intuition here is that networks will only transit traffic if it generates revenue for them. They're not going to do this if it doesn't generate revenue, or worse yet, it costs them money. You might notice this model has a lot of assumptions about how networks are going to behave in practice, and my goal here today is to validate how often these assumptions are holding in your networks and what sort of exceptions you're seeing. And if you see an exception, is this exception done usually, or is it just done in, say, a corner case? An example that really spurred this work was the following. Our model has this assumption that a network is going to want to route through a customer before it routes through a peer network. And when we look at the empirical AS graphs that are published by different research groups, we often saw this topology where you have AS1 on the slide here, and he has a settlement-free peering link to a content delivery network or a large content provider. However, when we looked into the topology, this AS also had a much longer customer path to the content delivery network. In this case, it doesn't seem likely that this AS is going to want to use this longer customer path when he has this direct settlement-free peering link. And really, one of my goals here today is to try to understand how often these sorts of cases are happening where you have a network who maybe would rather prefer a peering link over a customer link, as well as what other deviations do you guys see from these assumptions. We also want to understand how often this model holds. So if the routing in your network follows this model very well, I'd also be interested in hearing that. But I'm really interested in this notion of exceptions. So what sort of business situations are causing exceptions to happen? How often are they occurring? And what types of networks are having these exceptions? So if you're running a content provider, is your routing significantly different than that of, say, a Tier 1 network? So the challenge of answering the questions of this study is that, as we know, you guys all sit in different commercial organizations with different business goals. If you're running a Tier 1 network or you're running a content provider network, you have different functions that you're trying to optimize with your routing policy. And the goal here is really to understand this notion of exception versus the rule. So what exceptions are you seeing? But also, if there's a general consensus of how routing is being done on the internet, I'd be interested to know if there's something that most of the networks are doing. How we went about resolving these challenges was that we performed an informal survey of network operators about their routing policy, and it's the results of the survey that I'm going to be presenting today. And I want to emphasize here that the survey was very preliminary and there's still a long way to go. So part of the reason I'm here today is to ask for your help. We have another survey posted at the URL on the slide here. And please use the question time to give me comments, feedback, or approach me during the break or lunch to tell me more about routing policies in your network. So with that, I'm going to dive into our existing survey results. The routing policy survey we did was a basic web form that we circulated to the NANOG mailing list and other operator-centric mailing lists. It consisted of a set of yes-no questions about routing policies, and it gave the participants an opportunity to specify why they gave the answer they gave. And we also gave the networks an opportunity to specify what type of network they were operating. So after running this survey for a couple of months, we ended up with 100 responses, and the graph on the slide here shows the breakdown of the different types of networks that answered our survey. So we saw that roughly 3/4 of the networks were small to large ISPs, but we also saw some stub networks, tier 1s, and large content providers. Using the results of this survey, we wanted to validate the assumptions of our model, and we break these down into 2 basic categories. The first are assumptions about local pref. So our network's going to assign a higher local pref to pass through their customers. And is the local pref only going to depend on that next hop AS, as it is in our model? We also look at 2 assumptions about export policies. So this notion that networks will not export paths from non-customers to other non-customers, and whether or not networks are doing some sort of neighbor-specific path selection policy. So will you always send the same path to a destination to all neighbors of the same type? The survey also covered other topics such as MRAI, prefer oldest path, as well as some questions about BGP security that I won't be covering today. So with that, let's dive into this first assumption. The assumption basically says that a network is going to assign a higher local pref to a path through a customer than for a path through a peer or provider. So the AS on the slide here is going to want to route to his customer before he routes to his 2 other neighbors on the slide. To validate this assumption, we ask the question, do you always assign a higher local pref to a path through your customer than to a path through your peer or transit provider? So if the assumption holds here, what we're expecting is that most networks will say yes, they're going to prefer the customer path. And when we looked at the survey results, the assumption mostly holds, with almost 80% of networks assigning a higher local pref to pass through the customers. We then looked at some of the comments people gave here, and we saw things like, for the people that said yes, we saw what you'd expect, comments like, that's where the money flows, these are our customers, they pay us, of course we would choose to route to them. However, when we looked at some of the networks that responded no, we saw more interesting things such as, no, we don't use local pref. I'm not quite sure what sort of network wouldn't be using local pref, but if you aren't using local pref in your network, I'd be really interested to know why and what sorts of criteria you're using for selecting paths. So to summarize, we saw that assumption 1 holds for about 80% of the networks that answered our survey, and we can now look at assumption 2. So does the local pref depend only on the next hop AS? In order to validate this assumption, we ask the question, does your local pref configuration depend only on the next hop AS and not on other ASs on the path? So here we were interested in knowing whether networks were looking at other ASs on the path as well as just that next hop AS. And here again, if the assumption holds, we were expecting a yes response, but the result here was actually less clear, and we see that more than 30% of networks say no. Their local pref is depending on more than just that next hop AS. And here we really want to understand, why are so many networks having local pref depend on more than just that next hop AS? And we looked into the comments. We didn't find a really good explanation here, so we broke it down by the different networks that responded to our survey. What we saw is that when we look at tier 1s, it's unanimous. All of the tier 1s that answered our survey said yes, their local pref is depending only on that next hop AS. But when we looked at the large content providers, we saw more exceptions. For large content providers that answered our survey, they broke down roughly evenly between yes and no in terms of local pref depending only on the next hop AS. So if you're running one of these large content provider networks, I'd be interested to learn more about what sort of factors are impacting your local pref. So to summarize, for assumption 2, we saw that it didn't hold as strongly as assumption 1, and actually there tended to be more exceptions for the large content providers. Next, we take a look at the export policies and whether ASs are going to export paths from non-customers to other non-customers. To illustrate what I mean by this assumption, we have an AS on the slide here, and he's got a peer and provider. If the peer and provider send paths to this AS, he should only announce these paths onto customer networks. He should only send these paths onto customer networks and not onto peer or provider networks. In order to validate this assumption, we asked the following question. We said, do you announce paths from peers and providers to other peers and providers? So if the assumption holds here, the answer we're expecting is no, that networks are not announcing paths from non-customer networks to other non-customer networks. And in fact, when we looked at the survey results, we saw that this assumption mostly holds, with more than 70% of networks saying that they're not announcing paths from non-customers to other non-customers. When we looked into the comments here, when we looked into the no responses, we saw things like you would expect, networks saying, we're not interested in being an unpaid transit provider. However, when we looked at the exceptions, things were more interesting. We saw comments like mostly to be a good neighbor and secret agreements. So when these exceptions occur, I'd be interested to know if it's normal for an exception like this to occur, or is it a special case where you decide to be a good neighbor for some subset of your neighbors. And if you're transiting traffic for non-customers, I'd be really interested in hearing more about why you're doing this. So to summarize, we saw that assumption 3 held for about 70% of the networks. And next we want to take a look at assumption 4. So are networks exporting paths of the same type are they exporting paths to a given destination to neighbors of the same type that are the same? So just to clear this up, let's draw a picture. We have an AS on the slide here with a provider and a peer. The provider tells him one path to a destination prefix, and the peer is going to tell him another path to this destination prefix. If this assumption holds, the AS is going to export the same path to this destination to all neighbors of the same type. On the slide here, that's customers. So if he tells his customers about the path through his provider, he shouldn't have one customer that he's telling about this path through his peer. In order to validate this assumption, the question we asked was, do you do neighbor-specific path selection? For example, selecting a different path for different customers for policy reasons and not due to hot potato routing, etc. And if our assumption holds here, the answer we're expecting is no, that networks are not doing this per neighbor path selection. But when we looked at the responses, it was actually less clear-cut. We see that almost 40% of the networks say yes, they are doing neighbor-specific path selection. And when we look into the responses here, for the people that said no, it was what we would expect. They say that the policy gets too complicated if they select different paths for different customers for policy reasons. However, there's still this large number of networks that say they are doing per customer path selection. And we didn't find any satisfying responses in the text box. Again, we break it down by the different networks that answered our survey. And here what we see is that there tends to be more exceptions for the Tier 1 networks and large content providers. So for the Tier 1s and large content providers that answered our survey, more of them are saying yes, they do customer-specific path selection than are saying no. And so I'd be really interested in understanding why Tier 1 networks and large content providers are doing path selection on a per-neighbor basis. So to sum up for assumption 4, we see that most of the exceptions tend to be for Tier 1 networks as well as for large content providers. But I want to emphasize here that even when the assumptions hold, they never hold 100% of the time. We're still getting 20 to 30% of networks that are violating the assumptions that are made by this model. So really my goal here today is to get a better understanding of what sort of corner cases are causing networks to have these exceptions. Is there business situations that are causing routing policy to change? If you're running a specific type of network, do you place different constraints on your routing policy? And I'd really be interested in hearing more about your experiences in configuring routing policy. And if you're willing, I'd really appreciate if you could fill out the survey at the URL on the slide here or come talk to me during the break. So thank you. And with that, I'd like to take any comments, questions, or input you might have on this work.
We do have some time for questions, so if you guys have questions or if you've responded to the surveys and find something interesting, this is the time. So I do have one question. One of the things that would be interesting is to understand what's the geographic spread of the responses you've got. Is it primarily US or is it spread over?
We didn't have a summary of that. Since we sent it to NANOG first, it was probably more North America focused, but our eventual goal is to get a more worldwide view.
Yeah, I think it'll be interesting to see if what you're observing is different from different portions.
Yeah, anecdotally, I've heard Europe has kind of different routing policies and business relationships.
My name is Andrew Sullivan. I have a question because some of those answers were a little surprising to me too. I wonder how likely it is you think that some of these answers are just wrong, that is, people are reporting incorrectly to you what they're actually doing.
Yeah, so I mean, that's a very good point. This survey was very preliminary, and as academics, we were still trying to figure out how to phrase these questions in a way that the operators could understand what we were asking. I think it's definitely the case that some of these exceptions are occurring, but that's part of the goal with our new survey, is to get a better reading of what the operator community is doing and whether some of these exceptions we're seeing are happening often or if it's kind of a corner case. Because with a yes-no question, if someone's done this one time for one neighbor, they still technically could give you the unexpected response.
Can I ask one question? Has anybody in this room responded to the surveys that they sent out? So we have a few hands showing up. Okay. Let's thank our speaker.